Numerical 5 on moment of inertia. Numerical is a I section is 250 mm deep and plane side 160 mm by 10 mm. This is plane side, width 160 mm and thickness of planes 10 mm. Calculate moment of inertia. For solving this problem, first see center order axis. This dotted line is neutral axis x and this vertical line, straight vertical line is neutral axis yy. So this I section is symmetric about x axis and symmetric about y axis. See, this x axis upward side and downward side, both sides are symmetric. And see this y side, left side of this y axis and right side of y axis both are symmetric. So for solving moment of inertia about x axis, first consider this full rectangle. First consider this full rectangle and then after consideration of this full rectangle deduct this part. That means this rectangle side 160 mm, 160 mm and total height 240 mm. Minus this part and this part. This part is 160 divided by 2, that means up to this distance 160 divided by 2 up to this distance 80 minus 5, that means 75. This distance is 75 and this distance is also 75. Here 75, 75 and for this vertical distance it is 240 minus 10 minus 10. 240 minus both flanges, deduct from this 240, that means 220 and both these sections are same, A and this is also A. So moment of inertia about this x axis is I xx I xx is equal to this rectangle moment of inertia about x axis. This is x axis. Parallel to this x axis is 160. 160 as it is multiplied by 240 cube, that means BD cube divided by 12 minus, these are two rectangles, that means 2 and multiply by BD cube by 12. This is the x-axis. Parallel to x-axis is 75. That means 75 as it is multiplied by 220 cube divided by 12. Therefore, 160 into 240 cube divided by 12 minus 2 into 75 into 220 cube divided by 12 is 51.22 into 10 raised to 6 mm raised to 4. So this is moment of inertia about x-axis for this I section. Now for y-y axis, y is equal to, now for y axis, this is y axis. See here, this is y axis, and moment of inertia about this y axis is, first calculate for this first plane section, then this second wave section and third plane section. Add moment of inertia of this first plane section IYY axis plus second wave section IYY and third plane section IYY. See here, for your IYY is equal to IY1 Y1 plus IY2 Y2 plus Y3 Y3. That means this part is Y1 Y1, this part is, so see, this is top plane side and this is Y1 Y1, this is wave side, this is Y2 Y2, and this is bottom plane side Y3 Y3. So Y1 Y1 is parallel to vertical Y1 Y1 axis side is 10 as it is, 10 multiplied by 160 cube divided by 12, 10 multiplied by 160 cube divided by 12 plus IY2 Y2, this side is 220 into 75 cube divided by 12 and plus 10 into 160 cube divided by 12. Therefore, IYY is equal to 10 into 160 cube divided by 12 plus 220 into 75 cube divided by 12 plus 10 into 160 cube divided by 12. So 10 into 160 cube divided by 12 plus 220 into, this is not 75 IY2 Y2, this is 10. See, this side is 10 So 220 into 10 cube. Now solve. 10 into 160 cube divided by 12 plus 220 into 10 cube divided by 12 plus 10 into 160 cube divided by 12 is 6.845 into 10 raised to 6 mm raised to 4. This is IYY and this is IXX. IXX is greater value 51.22 into 10 raised to 6 mm raised to 4. That means XX axis movement of inertia is greater and YY axis movement of inertia is smaller. Thank you very much.